Today, we are going to unlock the secrets behind something you use every single second of your life, but have never actually seen. I want everyone to take out your smartphones or think about the lights above us. What makes them work? Yes, electricity. But what actually is electricity? Today, we are going to master the two twin forces that power our entire modern world: electric current and voltage. The nature of electricity. Note the subatomic particles involved in the flow of charges. So as you can see, this is atoms that contain protons, neutrons, and electrons around its orbit. Electric current results from moving charges. Electricity is the flow of electrons through a closed conducting path. So, it means electricity is the energy produced by the movement of tiny invisible particles called electrons. So this one. So everything in our world is made up of atoms, and these atoms contain even smaller parts: protons, which have a positive charge, and electrons, which have a negative charge. Now let's understand the movement of electric charges. So just like water flows through a pipe, electricity flows through wire. So study this picture and imagine that this is the electric current and this is the wire. So we define electric current denoted by I. As you can see here, when I say what is the unit symbol of current, so it is I, letter I, a capital I. Current is the rate of flow of charge. And when I say if more charges pass by in 1 second, the current is higher. So my question is, what is the standard unit used to measure electric current? And the answer is amperes. Amperes are amp. So if there are 10 columns of charge past a point in 2 seconds, what is the current? The answer is 5 amperes. Because the formula is I equals Q over T, or current equals charge over time. Now let's dig deeper about this electric current. Why do charges move at all? They need a push. The voltage is also called potential difference. Voltage is that the electrical pressure. Think of it like a water pump. No? So think of it like a water pump in a fountain. Without the pump, the water stays still. In an electrical circuit, the battery provides this potential difference. So what is the other name for voltage? The answer is potential difference. How about, can you answer this? True or false, a battery creates charges. What will be the answer? The correct answer is false. It only provides the energy. But, again, a battery creates charges. The correct answer is false, because it only provides the energy to move the charges already present in the conductor. So, next we have, so not every material allows electricity to flow easily, and that is the reason why there is resistance. So resistance is the opposition to that flow. So resistance opposes the flow of current. Imagine trying to run through a halfway filled with people. That's what electrons face in a resistor. So what is the unit of electrical resistance? The answer is it measured in ohms. So this is the symbol of ohms. Does a long wire have more resistance or less resistance than a short wire of the same material? So the answer is more resistance because the charges have to travel through more obstacle. So the factors like the material, the length, thickness, and temperature has something to do or can affect the resistance of the electric current. Inside a metal wire, atoms are arranged in a lattice, and some electrons are free to roam. When we connect a battery, these electrons are repelled by the negative terminal and attracted to a positive one. So again, electrons move from the negative terminal to the positive terminal, and the conventional current is defined as the flowing from positive to negative. So which direction do electrons actually flow? Again, from negative to positive. So next question, why are metals good conductors? Bakit kaya? Again, metals are good conductors because they have many free electrons that can move easily. So in reality, electrons do the moving. Now let's talk about the Ohm's law, the relationship. Did you know that the scientist George Ohm, so this word Ohm is come from his last name, George Ohm. So George Ohm discovered a fundamental relationship. So if you increase the push, the voltage, the flow, which is the current, increases. Again, if you increase the voltage, the flow or the current increases also. But if you increase the obstacle, which is the resistance, the current or the flow decreases. We use the triangle V equals IR to calculate these values. So if a circuit has a voltage of 12 V or volts and a resistance of 4 ohms, what is the current? So if you are finding the current, this one, your formula is I equals V over R. But if you find the voltage, V equals I times R. If you are looking for the resistance, R equals V over I. So if the voltage increases, the current increases. This is what we call directly proportional relationship. If resistance increases, the current decreases. This is the kabaliktaran, no? The dissimilar of or the opposite. So inversely proportional. If the resistance increases, the current decreases. Again, what happens to the current if the resistance is doubled while the voltage stays the same? The answer is the current is halved. Hello class, welcome to our new topic, which is the parallel circuit. In the previous video, we looked at series circuits where electricity has only one single path to follow. So remember how we said that if one bulb burns out, the whole string goes completely dark? Diba? Right? So imagine if your house was wired that way. Kung nga na ang inyong balay ba, isa lang ang outlet, ang wire, no? Ang connection, isa lang ang connection. You turn off the bathroom light. And if i-turn off nimo ang bathroom light or ang suga sa inyong CR, suddenly your TV, your refrigerator, your microwave, your washing machine, kung nagamit mong mama na kanang laba, it all shut down too. That would be a nightmare, right? So, thankfully, our engineers solved this problem using a brilliant piece of design. So, today, we are going to master the ultimate highway system of electricity, and that is the parallel circuit. Kung series circuit kay isa lang ang iyahang, no? Ang electricity, isa lang ka single path ang gina-follow. Ang parallel circuit kaya, unsa ka ni siya na klase na pagka-wired or ang flow sa electricity. Okay, ready? And let's learn about parallel circuit. Now, we think of a parallel circuit like a highway with multiple lanes. If one lane is blocked, no, cars can still move through the others. So, pasabot kung ang naidwa kagyanan or daghan kagyanan. So ang isa kagyanan gi-block, ang car nimo pwede pa siya makamove sa other na lane or sa other na agyanan. Ang ana po na ang parallel circuit. A parallel circuit is a type of electrical circuit where components are connected across the same 2 points, creating multiple paths per current to flow. So unlike a series circuit, if one path is broken, the others remain functional. So the key features are multiple branches, independent operations of loads, and shared voltage sources. So this is a fundamental concept in how our homes are wired. So, diba, kung palungon, pitan mag-sleep na ka, i-off nimo or turn off nimo ang imong lights. Dili pasabot na i-turn off imong lights, ma-turn off na pud ang lights sa imong mamagpapa dito or ang suga sa inyong kusina, sa sala. Dili, it's because ing ana man ang pagka-wired sa atong balay. That is how parallel circuit works. So in your own words, what is the main difference between a series and a parallel circuit regarding the path of the current? Okay, let's move on. We must speak the language of electronics. Look at these symbols. Notice that the battery has a positive and a negative terminal. So this one. When drawing your parallel circuits later, ensure that each branch is clearly defined. No? And the resistor, mauni ang symbol sa resistor. Kung magsulat po kag ammeter, mauni ang symbol sa ammeter. Ang voltmeter, maupo ni ang symbol sa voltmeter. The rule of voltage. So here is a crucial rule that voltage is a constant across all branches. If you measure the voltage at the battery and then at any bulb in the parallel setup, the reading will be the same. So again, this is the battery, and if you measure the battery, the voltage of the battery, as you can see, 9.00 voltage or 9 voltage. Even though lahi-lahi sila bulb, pero same lang man sila og source, which is kaning 9 volt na battery or 9V na battery. That's why ang iyahang kung i-measure nimo ang voltage sa tulo ka bulb, even though lahi-lahi sila, ang mogawas is 9 volts. Because any bulb in the reading will be the same because the appliances in your house has the same source. And if we total this one, 9 volts, and 9 volts, no? Kung i-measure na to ang voltage, so the V total equals the V1 is equal to V2 is equal to V3. So same lang dyan ang voltage 1, voltage 2, voltage 3. This means if you have a 9 volts battery, every bulb connected in parallels receives exactly 9 volts. So this ensures consistent brightness for all lamps regardless of how many are added. We look at this illustration and observe. So this is the electric current. Imagine that this is the electric current. Again, the symbol of electric, the current is capital I. I sub T, it means current total is equal to current 1 plus current 2 plus current 3. So if parallel ni siya, ang current 1 moadto diri sa first na wire, ang current 2 diri na wire, and current 3 diri na wire. Pero ang paggawas niya diri, kung i-measure ang voltage sa current, V total, V sub T or V volts total is equal to V sub 1 is equal to V sub 2 is equal to V sub 3. Kung unsang value sa volt sa V sub 1, mo pud ang value or number no sa or measure ana sa volts 2 and volts 3. So in the circuit identity, a parallel circuit has branches or multiple paths for current flow. So mao ni ang mga branches, mao ni ang path agianan. So the total current is the sum of branch currents. So again, mo to kung giingon no, kaning I sub T is equal to I sub 1 plus I sub 2 plus I sub 3. Itotal lang nimo ang current. But in the voltage across each branch is equal to the source voltage. Sa voltage naman, V total is equal to V sub 1 is equal to V2 and V3 and so on and so forth. Na ilahang kalahian kung i-measure nimo ang current o voltage sa parallel circuit. Think of the total current as a river that splits into smaller streams. So mo ni ang big river and it splits into smaller streams. So mo na ang path. So it just takes different paths. So we use an ammeter. Itong gipakita in the previous video, di ba, napakita ko sa inong sa ammeter. So the ammeter used to measure this one, and as you can see, the total current in a parallel circuit is the sum of the currents through each individual branch. So I total, or the current total, is equal to current 1 plus current 2 plus current 3, or the I sub 1 plus I sub 2 plus I sub 3. I-add lang nimo ang mga current. So that is the current total. The current splits at junctions and recombines later. The branch with the least resistance will have the highest current flow, following the Ohm's law. Again, the Ohm's law is I is equal to V divided by R, or the resistance. To observe this illustration, this concept is often counterintuitive. Usually, more stuff means more resistance. But in parallel, more resistors means more paths or agyanan. So imagine a crowded room. Adding more exit doors makes it easier for people to leave, right? So pareha sa room na to, isa ra man jud ang door, no, na pwede sudlan o gawsan. So that's why na maglisod lisod siya, no? Maglisod ta og ingon pa diri na ang lisod gawas. It's because gamay lang man ang path or agyanan. But sa parallel, kung more ang resistors, tong resistance ba, it means daghan ang agyanan. Adding more resistors in parallel actually decreases the total resistance of the circuit. Mas ipagamay noon niya ang naga-oppose sa electric current. So the formula is 1 over R. 1 over R total is equal to 1 over R sub 1 plus 1 over R sub 2 plus 1 over R sub 3 and so on and so forth. This is because you are providing more lanes for the electrons to flow through, making it easier for the total current to move from the source. So think about your Christmas tree lights. So if one goes out and they all go out, that's a series circuit. If one goes out and the rest stay on, that's a parallel circuit. So what are the advantages of parallel circuits? Number 1 is independent control. Turning off one device doesn't affect the others. Number 2, consistent voltage. It means every device gets the full voltage of the source. Number 3, reliability. If one component fails, the rest of the circuit stays live. This is why parallel circuits are used in residential wiring. For the limitations and safety, while parallel circuits are useful, they have limitations. Naa siya'y hangganan. So adding too many loads can draw excessive total current from the battery, leading to overheating or rapid battery depletion. In homes, this is why we use circuit breakers, or sa atong language is plangka, to prevent fires caused by overloading parallel branches. So mauni ang meaning sa inyuhang plangka. Kindly read na lang or pause the video so that you can read the parts of a circuit breaker. Parallel circuits are powerful but can be dangerous if overloaded. More branches mean more total current. If the current gets too high, sobra ra pud kadaghan ang current or agyanan, the wires get hot. No? So that is the limitations of parallel circuit. Now, for our summary and conclusion, today we learned that parallel circuits provide multiple paths, daghang agyanan sa kuryente. No? Multiple paths for current. The voltage remain constant. Dili daw magbago ang voltage. So for example, ang volt, kung i-measure nato pila ang total sa voltage, ang voltage 1 is equal to voltage 2. Pareha lang jud ang measure sa matag voltage. While ang current kay i-add lang nimo ang measure nimo ang tanang total current, i-add lang nimo ang current 1 plus current 2 and so on and so forth. So we also saw how adding resistors decreases the total resistance. So these principles are the backbone of modern electrical distribution and electronic design. So we've covered the math, the diagrams, and the practical applications of parallel circuits. You are now ready to design your own complex systems. And don't forget to review your notes on the Ohm's law as it applies to these branches. So great job today and goodbye everyone. I hope you learned something about this lesson. Bye! Hello class, welcome to our new topic, which is the main focus is all about electromagnetic waves. But we are going to discuss about the nature of electronic magnetic waves, the types of electromagnetic waves, its energy, the wavelength, and the frequency and its relationships. So today we are going to discover or explore the invincible world of electromagnetic radiation or EMR. So think about your daily routine. Waking up to sunlight, using a microwave for breakfast, or texting your friends. All of these involve EMR. So today, we will learn how these waves are created and how they move through the vacuum of space and how we categorize them based on their energy. So let's first define what is electronic magnetic radiation or EMR. It is an energy. Again, EMR is an energy that travels through space at the speed of light. So paspas kayo no. Energy ni siya na ni travel no through space. So kaya niya mulusot-lusot bisan asa and paspas kayo. So radiation man siya, dili siya makita sa tong naked eye. Pero nag-exist siya og naa siya, no? Naa siya, it's because of kanang makita nato sa atong gadgets or sa mga palibot nato ng mga electronics. So it is all around us. So again, unlike sound waves, EMR does not need a medium like air or water. So dili niya kailangan og bagay or something para mo exist siya or para mo sulod siya. So again, EMR does not need a medium like air or water to travel through. So understanding EMR allows us to master modern technology. Again, the electromagnetic radiation, it occurs naturally around us, such as the sunshine, the thermal radiation, radio interference from lightning strikes, and the signals that radio astronomers gather from space. Appliances like microwaves, televisions, and computers use electromagnetic radiation. So since different devices use electromagnetic radiation, each is confined to a specific part of the electromagnetic spectrum. So my question is, what do cell phones, a radio, and an X-ray machine have in common? Alright, do you have an answer? And the answer is, they all use electromagnetic radiation or EMR. Electromagnetic radiation is an energy in motion from one place to another. It exists all around us and it is used in many ways for technology. What is the nature of EM waves? So my question is, how do these waves start? Paano ba ito nagsimula? So it all begins with a charged particle, like an electron. So electron na makita sa atom, no? That moves back and forth, or it vibrates. So this movement, again, the EMR is created by the vibration of electrically charged particles, or what we call the electrons, no? These vibrations produce oscillating electric and magnetic fields. So it moves back and forth. Ano ba? Back and forth. So this movement creates a ripple effect in the electric and magnetic fields around it. So these fields move at right angles to each other and to the direction of wave travel. So study this 3D diagram how EM waves move. So did you know that EMR is a kind of transverse waves? So think of a stadium wave at a sports game. So people jump up and down, but the waves move sideways. That's a transverse wave. In a transverse wave, the displacement of the medium is perpendicular to the direction of the wave's motion. So when we say perpendicular, 90 degrees jud na. Kung i-measure na to ni 90 degrees jud ang kung i-measure na to ang direction sa wave. And in EM waves, again, the electric and the magnetic fields oscillate up and down, side to side, while the energy travels forward. Pa-forward na siya. So these allow EM waves to travel through both materials and the vacuum of space. So kaya niya mulusot, no, mo travel sa isa ka material o vacuum space. So, to understand different types of EMR, we have to look at two measurements, the wavelength and frequency. Now, let's define wavelength. So, this is a symbol of wavelength. You will read it lambda. Lambda. So, it means the distance between two consecutive crests or troughs. So, next is the frequency. Frequency, the symbol is small letter f. It means the number of wave cycles that pass a point per second. It measured in hertz. Capital H and small letter Z. Hertz. So kindly pause this video and read this illustration so you can distinguish the difference between wavelength and frequency. So all EM waves travel at the speed of light, which is c is equal to 3.0 times 10 to the power of 8 meter per second in a vacuum. So again, the wavelength is the literal length of one wave cycle. Again, wavelength, the wavelength, one wavelength, and this is the wavelength. So kung mao ni ang noun sa wavelength, wavelength is the literal, no, na length of one wave cycle. Frequency is how fast they are vibrating past you. So it means even the waves can have very different lengths, they all have one thing in common in space. Say they all travel at the same incredible speed. No, they can travel 300,000 kilometers per second. Remember that? Again, even though ang waves daw, kaning wavelength, no? I mean, the EM waves and the other waves have different lengths, but they all have one thing in common in space. They all travel at the same incredible speed, which is 300,000 kilometers per second. Ana siya kapaspas. The inverse relationship. Remember that wavelength and frequency have an inverse relationship. Kana, when we say inverse, kay kung ang isa mo taas, ang isa mo baba. Ana, mo na ang inverse relationship. This is a crucial concept for your to know about the wavelength and frequency. So, ang wavelength of frequency is like a seesaw. Kanang tuya-tuya ba sa park gani nga na. If one goes up, the other goes down because their product must always equal the speed of light. So as wavelength increases, ang frequency mag-decrease. As wavelength decreases, ang frequency mag-increase. So the fundamental formula connecting frequency and wavelength is P, which is the speed of the wave. V is equal to F, the frequency, the wave speed. Again, V is the wave speed, is equal to F where it is the frequency, and lambda, it is the wavelength. So remember this formula in finding the wave speed of a wave. So energy is all about the wiggle. The more times a wave vibrates per second in a higher frequency, the more energy it carries. Again, the energy of an EM wave is directly proportional to its frequency. When we say directly proportional, kung mataas ang isa, kung saan, if one goes up or increase, the one also increase or goes up. So, mo na ang relationship sa EM wave, ang energy sa EM wave ug ang frequency. So, kung higher ang frequency, higher ang energy. Kung lower ang frequency, lower pud ang energy. So, this explains why some waves like radio waves are harmless. Ang waves sa radyo ba, harmless siya. While others like gamma rays can be dangerous. So, ang radyo, kung maminaw ka, diba, dili man siya sakit sa dalunggan, dili siya wala siya bad effects sa tuwa. Pero, kung dito na sa mga x-ray or mga gamma rays ka nang taas na jud kayo siya og energy ba, mo na delikado sa ato na siya effect sa ato ang lawas. Kay dili makaya sa atong lawas og taas kaayo na energy. No? Kaya na ba tayo energy da? So we organize all these waves into a map. It is called the electromagnetic spectrum chart. So pause this video and kindly familiarize the concept. What waves belong to the low energy, what are waves belong to high, papunta na sa high energy, and katong nasa middle lang, which is the visible light, yung sa makita sa atong naked eye. And unsa ang nang sa wavelength kung paingon sa low energy, ug unsa pud ang frequency, unsay nang sa frequency kung paingon na sa high energy. And this is the photon energy, kung pila ang energy sa matag waves. So the EM spectrum is the range of all types of EM radiations. Tanan electromagnetic radiation na siya tanan. Arranged by frequency and wavelength. So naka-arrange siya by frequency or wavelength. Ang order niya, longest to shortest, lambda. And from the radio wave, microwave, infrared wave, visible light, ultraviolet, X-ray, and gamma rays. So remember the the order from longest shortest wavelength. So on one end, we have waves as big as buildings, no? As you can see on the radio. Nabilong diri ang radio waves. And on the other end, the waves are smaller, no? Pagamay na iyang wave. Smaller than the nucleus and of an atom. So this is the gamma rays. We are going to explore each of these 7 regions now, starting from the longest waves to the shortest wave. Did you know that the electronic magnetic radiation, or the EMR, used in telecommunications and medicine? So in telecommunications, the specific examples used are, it includes the radio waves for broadcasting radio and TV signals, and microwaves for satellite communication. So nabilong sila sa radio waves. While in the medicine, ang EMR niya is utilized in X-rays for diagnostic imaging, CT scans, and radiation therapy for cancer treatment. So again, for the telecommunications, ang radio waves, makita na siya sa radio, no, sa radio station, TV, matanatag TV, magamit occur ang radio waves. In the microwaves, gamito na siya sa satellites, and in the medicine, no, ma-apply dira ang mag-apply sa ang EMR sa X-ray. Ang sa may plus ng X-ray, so for diagnostic imaging, CT scans kana kung imong for example, if nakatry ba mo ka na, if masakit gani, labi na anang asmahon ka, o buhon, pneumoniahon, or basta, naa siya pahubuon ka, and then ay pasuti mo sa nina, and then i-attach ni mo imuhang dughan dito sa murag TV, and then, inan ka sa katong staff dito, nurse staff dito na, inhale, exhale, tapos na mo kalitig-click, nga, moto, oo na to ang X-ray, kaya makita ang sulod sa imuhang lawas. Gamitan na siya EMR. Next is radiation therapy for medicine. No, gamit kayo siya sa medicine to treat cancer people. Sa industry, ang EMR magamit siya sa materials testing, non-destructive inspection, sterilization using gamma rays. Again, let's discuss about the radio waves. No, kaganiha kay simple lang man atong discussion about the radio waves. So, may example ana. Now, let's dig deeper about the radio waves. Did you know that radio waves, it is the longest waves? So, radio waves are the giants of the spectrum. They can be kilometers long because they have low energy. They pass through walls and obstacles easily, which makes them perfect for communication. Mo nang ginagamit ang radio waves for communication sa TV, sa radio, o kanagaling sa walkie-talkie, ana. Pwede siya. Sa car radio, sa antena sa balay, and mag-transmit kaning, as you can see, kaning antena, nagka-produce na siya radio waves. So, ang longest wavelength ang radio wave has the longest wavelength and lowest frequency or energy. And sa may use sa radio waves, it is used na ginagamit siya sa radio, sa TV broadcasting, sa radar, and satellite communication. So, if mga tanak ko, give me an example how radio waves used in our daily lives is, you can answer this following. Okay? Next, microwaves and infrared. So, moving up the spectrum, we reach microwaves and infrared. Microwaves is used in cooking, mobile phones, and speed cameras. So, ang microwaves, it vibrates water molecules in your food. Heat it. So, kung na water molecules dira, gina-vibrate niya para mag-create og init. That's why kung maggamit kag microwave oven para initon imong sudan, tingala ka nganong niinit man na wala man tay kalayo dira. It's because ginagamit niya, nagamit siya microwaves, gina-vibrate niya ang water molecules. Pag vibrate, diba? Pag sige nag-vibrate, mag-create na siya heat. That's why, no? Ang asa man gikan ang water, ma'am? Water nagikan sa imong food, no? That is the time na mag-init na imuhang food. While the infrared or IR felt as heat used in remote controls and thermal imaging. While ang infrared naman is what you feel as heat from a campfire or a radiator. So, for example, kanang ani na lang naglungag mo kay naamoy dili sa gas stove kana agong sa kahoy ana sa kalan. So, ang init ana ginatawag na siya kanang na-feel nimo na init nagikan sa kalan kay dito ka naglungag dili sa gas stove, mao na ang infrared, no? So mao na ang init sa what you feel as heat. So next is katong sa remote control, di ba? Makita na nimong ula dira sa ibabaw tumoy na anay lingin dira niya. Pag pislito nimo ang remote, musiga siya. It's because it uses infrared para makontrol nimo ang TV, no, using the remote. So that is the use of infrared and microwaves. Now let's move on to visible light. The colors we see, no? Thank God we have eyes so we can see how beautiful the world, no? We're thankful jud, pasalamat jud sa Ginoo na atay tarong na mata na maka-distinguish ta, maka-identify ta unsa ni na material, unsa ni na color, unsa ni na gamit ana kay dili biya tanan, no, kanang ang uban kay color blind. It means ang na sila mata makakita sila pero dili sila ka identify unsa na color because color blind man sila. Ilang pananaw kay white lang tanan, black lang tanan ana. So visible light is just a tiny sliver of the whole spectrum, but it's the most important for our vision. So each color has a different wavelength. Muna bi since kita man ta og mga lights, no, mao ni ang visible light. Roy G. Biv. Sa man Roy G. Biv, red, orange, yellow, green, blue, indigo, and white. Nandiyo na to tong mata, dili na to abusuhon, no, labi na ka na magsigit gamit og gadget kanang pila na ka hours nagsigtutok sa gadget. Isa na sa mga rason nga nung mahanap atong mata hantod sa maguba na jud ta kaklaro. So the colors, the only part of the spectrum human eyes can detect. So mora niya to ma-detect na colors o ang combination ani na mga colors. The colors follow the acronym Roy G. Biv. Remember these visible lights? So each color has a different wavelength. Kahilahin ni sila og wavelength. Red has the longest. Ang red ang pinaka-longest wavelength. And ang violet has the shortest wavelength. Now let's proceed to ultraviolet radiation or UV ray. UV radiation has enough energy to penetrate the surface of our skin. So, pwede jud siya makapenetrate. It means pwede siya makasulod ba? Penetrate the surface of our skin. So, in the higher energy than it has a higher energy than visible light. It produced by the sun. So, gikan na siya sa sun ang UV radiation. in small doses, it helps our bodies to make vitamin D. So, pwede siya. Gamay lang na UV rays, pwede ra siya maghatag sa ato og vitamin D. But too much can damage our DNA. Kung sobra na po mo nang nagagamit ang sunscreen, no? Kay para dili kaayot maguba ang atong skin, di na magkaroon ng skin cancer if sobra na ang energy or UV rays na ma-absorb sa atong skin. So may gamit sa ultraviolet radiation, it says sterilization, vitamin D production, and security marking. Sa may risk niya kung masobraan tag UV radiation, it can cause sunburn and skin cancer. Now we are at the high energy end of the spectrum, the X-rays and the gamma rays. X-rays, we define it as high energy. It can penetrate into soft tissue but are absorbed by bone. So this is the illustration of X-rays. X-rays are powerful enough to see through your skin to your bones. That's why ginagamit na siya sa hospital, di ba? Kung magpa-X-ray, kung para makitaan kung naaba kay balik sa imong bone, no? Or na something wrong sa sulod sa imong lawas, especially para makita dito kung nabay muscle or especially the bones jud ginatanaw niya kung naabay something wrong, dislocation or broken sa imong. Next, we have the gamma rays. It is the highest energy and frequency. Again, kung ang radio wave mo ay pinaka-lowest energy o lowest na frequency, ang gamma rays, it has the highest energy and highest frequency. It produced by nuclear reactions. Gamma rays are even more powerful and are often used in cancer treatments to kill tumor cells. So this is how we picture out the gamma rays. Pause the video and study this illustration. Alright. Now let's proceed to the comparing wave types. So pause this video and study this illustration or graph. So comparing the 7 types of EM waves. Frequency increases, nagataas ang frequency from radio to gamma rays. While ang wavelength increases, kabaliktaran sila, while ang wavelength naman naga-increase from magsugod sa gamma rays to radio. So energy follows the same trend as frequency. So ang energy naman mag-follow siya sa unsap ang frequency. So remember the order of the spectrum. So if you remember the order of the spectrum, you know the trends. Frequency and energy, ang frequency of energy are friends. They have direct proportion. They are direct proportion. They go up together. While wavelength is the opposite. Opposite ni si wavelength kay they have an inverse relationship between the frequency and the energy. So remember this important point in our lesson. Almost every piece of our modern technology relies on EMR. So in the real-world devices and research, we can use in mobile phones, we utilize microwaves and radio waves to transmit data. In the MRI and medical imaging, we use different parts of the spectrum to see inside the body. Satellite telescope, we use infrared and X-rays to study the stars. Yes, we've covered a lot today. So from the vibrating of electrons that start the wave to the gamma rays at the edge of the universe. So remember, EMR is created by vibrating charges and moves as transverse waves. The EM spectrum, or the electromagnetic spectrum, is categorized by wavelength and frequency. Wavelength and frequency are inversely related, or they have an inverse relationship. Energy is directly proportional to frequency. They are friends, no? If one goes up, they go up together. So every part of the spectrum has vital uses in our daily lives. So remember, the longer waves have less energy and the shorter waves have more energy. Use this knowledge to look at the world differently. Every time you see light or use a phone, you are witnessing the power of electromagnetic radiation. I hope you learned a lot from this video lesson. Until next time, study hard and put your trust in the Lord. Thank you for listening. Goodbye.
That's all for now. Thank you for watching. Don't forget to click like, subscribe, share, and comment down below your learnings from this video. Bye class.